All right, let's jump right in. Today, we are going to dig into a question that seems so simple on the surface, but it's one that has totally stumped scientists for decades. And it really gets to the core of how your mind works. We're going to take apart a huge myth about your attention. So, think about it for a second. How many things can you actually focus on right now, at this very moment? Is it one? Maybe four? Well, it turns out the answer changes depending on who you ask. And as we're about to see, the question itself might be the real problem. So, for a long time, the main idea in cognitive science was this. Your focus of attention is basically like a little container. You can pop things in there, but it's got a super limited capacity. It's a nice, simple metaphor that makes sense, but it leads to one big question. Just how big is this container? And that simple question kicked off a huge scientific showdown. You had researchers like Nelson Cowan on one side, arguing that this container holds about four different things. And then on the other side, you had scientists like Brian McElroy who were absolutely convinced it could only hold one single thing at a time. So who's right? Well, to try and settle this, researchers set up all these clever experiments to measure the container's size. But instead of getting a nice, neat answer, the results were, well, they were all over the place. The clues just weren't adding up, and it created this genuine scientific puzzle. Let's look at two of the key experiments that seem to completely contradict each other. Okay, so case number one. This comes from an experiment by a couple of researchers, Oberauer and Bielkova, and what they found seemed to point directly to a focus of attention that can only handle one single, unified chunk of information. So here's how they set it up. Imagine I tell you to memorize that the color red equals the number 7 and green equals the number 2. Then I flash a problem on the screen like red plus green. You have to super quickly pull those two numbers from your memory, add them up, and give the answer. Now, the real key here is that the scientists are timing how fast you are from one problem to the next. And what they found was really, really weird. People got this massive speed boost, a huge benefit, but only when both numbers from the last problem were used again. If just one number was reused, there was barely any benefit at all. It was as if their brains were treating the two numbers as a single, inseparable chunk, like red and green. If you couldn't reuse that entire chunk, you basically had to start over from scratch. But then, another experiment comes along that tells a completely different story. This study by Gilchrist and Cowan seemed to show that our focus can totally hold multiple separate items, no problem. The setup for this one was a little different. You had to memorize two different sets of pairs. Shapes go with letters and colors go with numbers. Then you'd see a shape and a color on the screen together, let's say a red triangle. Your job is to find the letter for the triangle and the number for the color, and then click on that coordinate in a grid, so in this case, Y4. And get this, the results were the total opposite of the first experiment. In this task, just reusing one of the items gave people a really solid speed boost. Reusing both gave an even bigger one. This is what's called an additive pattern. Each piece of information added its own little speed benefit, which strongly suggests they were being held as separate, independent things in your focus. So now we've got a real problem, right? We have two perfectly good experiments that lead to two completely contradictory conclusions. One says your focus holds a single chunk, the other says it holds multiple separate items. How can they both be right? I mean, what is going on here? This is the exact kind of puzzle that forces scientists to take a huge step back and rethink everything. And that big rethink actually came from Klaus Oberauer, who was the lead scientist on that first study. He eventually realized that to solve this whole puzzle, they had to just abandon the old question. This whole debate about what was in or out of the focus of attention, it was a total dead end. And it turns out that was the entire issue. They had been asking the wrong question all along. The problem wasn't with the experiments themselves. It was the whole obsession with trying to measure the size of this imaginary container. The real answer wasn't about how much we can focus on, but how our brain actually gets the information it needs. Let's just frame it this way, because this is the crucial shift. The old question was all about capacity. How many things can you fit in the box? The new and much better question is about mechanism. How are those items being pulled out of your memory when you need them? See, this is a huge shift from thinking about a static space to thinking about a dynamic process. So, according to this new way of thinking, our brains have two different, really flexible ways of grabbing information. The first is called serial retrieval. You can think of this like going down a checklist, grabbing things one by one. The other is parallel retrieval, which is more like grabbing a whole handful of things all at once. And believe it or not, this one distinction is the key that unlocks the entire puzzle. Okay, so let's look at serial retrieval. If you need item A and item B, your brain goes, okay, get A, now get B. Your total time is just the time for A plus the time for B. It's simple addition. So if you get a little speed boost because you just used item A, your total time gets faster by that exact amount. The benefits just add up, which is exactly what we saw in that grid task. But parallel retrieval? That's a whole different ballgame. Here, you start fetching A and B at the exact same time. But, and this is the important part, the whole process isn't finished until you have both of them. That means your total time is determined by whichever one takes longer to get. So, speeding up just one of them doesn't really help you much if the other one is still lagging behind. This perfectly explains why you only get that massive benefit when both items are sped up, just like in the arithmetic task. So once we have this new framework, this idea of serial versus parallel retrieval, we can go back and look at those two conflicting experiments. And suddenly, it all makes perfect sense. The puzzle just solves itself. Check this out. It all lines up perfectly. The arithmetic task, where you have to combine two numbers to get one answer, naturally encourages your brain to grab both numbers at once. That's parallel retrieval. And that's why you see that weird over-additive pattern. Meanwhile, the grid task, where you're finding two separate coordinates, encourages you to find them one by one. That's serial retrieval. And that's what creates the nice, neat additive pattern. The results were never actually contradictory. They were just showing us the most efficient strategy for that particular task. And this brings us to the really big conclusion here. That simple, intuitive metaphor we all started with, the whole idea of our attention being a container with a fixed size, it's just wrong. It's fundamentally misleading, and it sent scientists down the wrong path for years. Which means the question that we all ask ourselves, how many things can I really focus on at once, is actually the wrong way to think about it entirely. The real question, the much more powerful question, is how is my brain accessing this information right now? Is it pulling things out one by one, or is it grabbing them all in one go? Attention isn't a space. It's a flexible, dynamic process. So what's the big takeaway for you in all of this? Well, first, stop thinking of your focus as some limited resource that you can fill up. It's not a box. Instead, you should think of it as a dynamic process. Your brain is incredibly smart, and it's always automatically choosing the most efficient retrieval strategy, serial or parallel, for whatever you're trying to do. And that leaves us with one last thing to chew on. The container metaphor for attention was simple, it made sense, and it was ultimately wrong. It actually limited our understanding for a long time. So the question to leave you with is this. What other mental metaphors that you use every day, like, say, the brain is a computer, might be shaping and maybe even limiting how you understand your own mind?